All right, let's talk about something that we all see as the ultimate symbol of protection, the bulletproof vest. But what if that symbol has a surprising and kind of scary crack in its armor? Let's get right into it.
So, how bulletproof is a bulletproof vest, really? Seems like a simple question, doesn't it? But for the people who actually rely on this gear every single day, the answer is, well, it's anything but simple. We're about to break down a critical weakness that most people have no idea about, and it all starts by questioning what bulletproof actually means. Okay, so let's start with what we all think we know. In the movies, on TV, and video games, personal armor is basically an unstoppable force field, right? It's always shown as this guaranteed lifesaver.
And the word Kevlar itself has become shorthand for being totally impenetrable. You hear it and you immediately picture this perfect shield that stops bullets, no questions asked. It's a really powerful and honestly a reassuring idea, but it's an idea we need to take a much closer look at.
But what if the situation isn't as clean as a direct head-on hit? What if just the angle of attack changes everything? This is where our whole perception of safety is about to meet a pretty startling reality.
And there it is. This is the core finding from the source material. This one sentence completely flips the script on that myth of the invincible vest. It's saying that a super common type of bullet can get through a standard Kevlar vest. All it has to do is hit it from the side, at an angle. So what in the world is an oblique angle? It's actually way simpler than it sounds. Instead of hitting something straight on, like a hammer hitting a nail at 90 degrees, an oblique impact just strikes it at a slant. Think about a stone skipping across water. That's a perfect example of an oblique angle in action.
And the threat we're talking about here? It's not some crazy exotic armor-piercing round. Nope, we're talking about a standard 9mm full metal jacket, or FMJ. This is one of the most common handgun rounds on the planet. So this isn't some rare theoretical problem. It's a very, very real-world scenario.
So you have to be asking, right? Why does this weakness even exist? How can something designed specifically to stop bullets fail in this specific way? Well, it all comes down to how these vests are actually tested in the first place.
The official certification process, the standard that says a vest is safe, almost exclusively uses direct front-on shots. The tests are literally designed to measure how well the vest absorbs the straightforward kinetic energy from a perpendicular 90-degree impact.
And this slide just lays out that disconnect perfectly. On one side, you've got the standard test. Clean, direct 90-degree hits. That's what the vests are built and certified to stop. But on the other side, you've got the unseen threat, the messy, oblique, angled impact. In the chaos of a real situation, a perfect front-on shot is anything but a guarantee. So this is how it all goes wrong. See, a Kevlar vest works like a super strong net, right? The fibers weave together to catch and flatten the bullet, spreading its energy out. But when that bullet hits at an oblique angle, it doesn't slam into the net head-on. Instead, it can actually push the fibers apart, almost like parting a curtain, and just slip right through the weave. The whole defense mechanism just gets completely bypassed. Okay, so what does this all mean? What's the critical takeaway here for safety and for the future design of personal armor? Let's zoom out and look at the bigger picture. It means we really have to rethink our assumptions. It proves that standard testing doesn't always capture the full picture of real-world threats. This angled impact is a huge and often completely overlooked vulnerability, and the source is clear. A lot of standard vests are going to fail against this kind of impact. It basically reveals a massive potential blind spot in how we certify safety equipment. Now, it's not all bad news. The source material does point towards a potential solution. It turns out that laminated Kevlar, where the layers of fiber are all bonded together, is way less susceptible to this problem. That lamination makes it a lot harder for the fibers to be pushed aside. So this shows the problem isn't impossible to solve. It just requires a different way of making the vests. And that leaves us with a final, really important question to think about. This gap between a controlled test and chaotic reality, it's probably not unique to body armor. It makes you wonder, doesn't it? What other safety standards that we rely on every single day might have a similar blind spot? That's a crucial thought to carry with us.